So first of all, we want to understand data with summary statistics. Basically, we're just using statistics to understand our data in simple terms. Maybe we want to get insights like the mean, median, or standard deviation of our numerical data. Here's an example to get summary statistics. Using the Pandas library in Python, we can use print df.describe. And this output comes out for our age and the p-class. It has the counts, the means, the min, and the max. So we can easily just get more information on the categorical data that we have and, like I said, get the summary statistics. Now let's move on to our visualizing data. And basically we can do this with a variety of graphs. First, let's start off with histograms. Now, when do we use histograms? We use these when you want to understand the distribution of a single numerical variable. This means seeing how frequently different values occur within that one variable. How does this help us in data science though? First of all, it helps us identify the shape of the distribution. Is it normal, like a bell-shaped? Is it skewed, meaning does it lean one side more than the other? Is it maybe bimodal or multimodal where there are multiple peaks? This can inform the choice of statistical tests and machine learning models that we could use. Of course, we're not getting that deep into it, but once we would dive more into data science, that's basically how you would use it. Additionally, you can detect outliers. Unusual bars that are far away from the main distribution might indicate an outlier that needs more investigation or special treatment. Now, we can think about understanding the range of values. You can quickly see the minimum and maximum values and where most of the data points are concentrated. Next up, we have feature engineering, which I had mentioned before. The distribution might suggest different transformations, for example, skewed data, and this can help make the data more suitable for some certain modeling. Lastly, we can compare distributions. You can create multiple histograms, for example, for each category of another variable, and you can visually compare how a numerical variable differs across multiple groups. Let's move on to our next type of graph, a bar graph. When do we use these? Well, you can use these when you want to display and compare counts or frequencies of different categories of categorical variables. You can use them to show the mean, summary statistics of a numerical variable for different categories. For example, in this one, our different categories are different classes in a school and then the number of people taking it. Now, how does this help in data science? Well, number one, understanding the categorical distributions. You can easily see which categories are more frequent or tend to have the highest counts. This is important for understanding the composition of your data. Next, we can also compare categorical groups. Bar graphs easily allow for direct visual comparison of the sizes of the different categories. Now, with this bar graph, we can easily tell which course is taken more compared to less. Next, we can visualize relationships easily when the height of the bars represent a summary statistic, for example, like a mean of a numerical variable within each category. You can visualize how that numerical variable differs across categories. Alright, next up, let's move on to scatter plots. Now, when do we use scatter plots? Well, these we can use when you want to visualize the relationship between two numerical variables. How do these help us in data science? Well, first of all, we would identify the correlations. You can visually assess if there's a positive, negative, or maybe even no correlation between two variables. In this example, we can see a positive one, where if one variable increases, so does the other, creating a strong positive relationship, compared to maybe a negative relationship that we can sort of see over here, where when this variable is increasing over here, this one is slowly decreasing, causing this negative relationship. Sometimes there might not even be no relationship at all, as we can see with all these scattered variables. Next, we can also detect nonlinear relationships. These scatter plots can reveal nonlinear patterns, like a U-shape, that correlation coefficients might miss. Next, we can also identify clusters. These are groups of points just clustered together, and these might indicate underlying segments or patterns in the data. Additionally, we can find outlier detection. Points that are basically far away from each other from the main area of the data points can be basically, obvious outliers in our data. Basically, as we can see, most of our data for this one is over here. So this spot and this spot could be identified as outliers. Next, we have feature selection. Understanding the relationship between these features and the target variable can inform feature selection for modeling. For example, a strong correlation between a feature and the target might suggest its importance. Alright, and let's move on to our last one, box plots. Now, when do we use box plots? These are used when you want to summarize a distribution of a single numerical variable and identify potential outliers, especially when comparing the distribution across different categories. How do these help us in data science? Well, first of all, we can visualize key statistics. The box shows the IQR, or the interquartile range, which contains the middle 50% of the data. The line inside the box is the median, which is the 50th percentile, and the whiskers, over here, extend to show the spread of the data, and points outside the whiskers are often considered outliers. So if there was any data over here, those are our outliers, which you can easily see as the whiskers go off to certain min and max point. Next, we can also compare distributions across groups. Box plots are excellent for visually comparing the central tendency, spread, and presence of outliers of a numerical variable for different categories. Other than that, we can also identify skewness. The position of the median within the box and the length of the whiskers can indicate the skewness of the distribution. Lets us know if it's going more towards the right or the left. And like I mentioned, outlier detection. Points plotted individually beyond the whiskers are potential outliers that might require, once again, further investigation or handling. Now again, if we see some outliers in our data, this might mean that we might have to go back and maybe see if there's any problems with our data sets where we have to clean or organize it better. Or maybe that's just how our data is. Maybe there are just outliers. Thank you so much for watching. I hope you gained a deeper understanding of how to explore your data, visualize it better for when you're finally creating a model of your data sets. And I hope in this course that you were able to learn how to collect your data thoroughly, being able to clean it and organize it properly, and also, of course, learning the small details of what types of data there are, where you can get it from, and then, of course, like we learned in this video, being able to visualize it and create a nice visual model of it. Thank you so much for watching, and I hope everyone enjoyed this course and learned a lot.